Welcome developers. In this video we will cover about the prime numbers and the composite numbers. You would have faced such problems related to the prime numbers and the composite numbers in the interviews. Interviewer would have asked you how can we identify whether a number is a prime number or not, considering the time complexities, how we can calculate the divisors of a given numbers. So we will cover all these things here. So before I move ahead, let's understand what is prime number first. So prime number in mathematics are the numbers which has exactly two divisors like 1 and itself. If it has more than two divisors, then we will call it as a composite number, not a prime number, right? So here is the function Primality test. So we will write this function and we will understand the mathematical background behind the prime numbers. Before I move ahead, let's cover these points first. Key insights. If A is a divisor of n, then n by A is also a divisor. We will call it as a symmetric divisor, generally symmetric pair. At least one of these two divisors, A or n by A, must be less than or equal to under root n. This is a mathematical proof. Proof is given here. You can skip this line, but it is a proof that your A or n by A must be less than or equal to under root n. So what is the conclusion of all these points? It is saying thus checking divisibility up to under root n is sufficient to cover all possible divisors. That is the conclusion. You must note it in your mind. So let's look at here. So we don't have to iterate up to the n, we just have to iterate up to the under root n. That is what we got it from the mathematics. Now let's check first if your I, or let's say your n, generally it is equal to the 1. In that case we just have to return your 1 itself generally, or let's say n. Let's say if n is equal to 2, then 1 has only one divisor, so we will return itself. So here what we will do, let's declare one variable result. Let's say result starting with the 0. We will use this variable to count the number of divisors of that number n. So here is the main logic. We will write a while loop. Here we will write the main condition I square, generally less than n. We can also call this condition as I less than under root n. As we got this condition from the mathematics, we don't have to iterate up to the n, we just have to iterate up to the under root n. Here we will write another condition. If n modulo by I, if it is equal to 0, that means it is a divisor, right? So we will count it. Let's count it, and we will count it as 2. We'll add 2 at a time. This is because first, let's say I is one divisor, right? And n by I, that is also one divisor, symmetric divisor. So we will add 2 at a time. That's why we are adding it. Now here we will increment your I by 1, right? So we got here. Now here is one more condition. You must note it. This condition is a special condition. I multiply by I. If it is equal to your n, that means it is a perfect square. In this case, just add one more here. We don't have to add 2 here. This is because if you see 36 is a complete perfect square, right? So we will count a single divisor because both are same. That's why we are adding just once here. Now at the end, we will return n plus generally your result plus 2, because every number generally has two divisors, 1 and itself. That's why we are adding 2 here. Now let's run this and we will get the number of divisors of each number, as these are the inputs 5, 36 and 39. Let's run it. There is issue. I less than n. Actually, what is this saying? Reference either I is not defined. Okay, yeah, let's declare I as well. Actually, it's very easy. Don't have to worry. So we will start our I by 2 because we already returned here 1 itself. So we will start it from the 2. Now let's. So as you can see, we got the divisors of each number. 5 has 2 divisors. 1 and itself. It is a prime number, right? 5 is a prime number. 36 is not a prime number. It has 9 divisors. Similarly, 39 has 4 divisors. Now let's check. If I put here, let's say 79. So how many divisors will be there for 79? Is it a prime or composite? Let's console it once. Yeah, we got 2 only. So this is how you can identify whether a number is a composite number or a prime number. So you are able to calculate the divisor successfully here. So now we will write another function here. We can just remove it here. Let's remove it here. Let's say if you are supposed to find out whether your number is a prime or not in quick steps, in few steps only. If you are supposed to check the primality of that number, if you are not calculating any divisors or something, so what you can do here in quick steps, let's declare a variable I. Okay, so what you have to do, you must note it. As we know from the mathematics, you like iterating up to the under root n is sufficient to calculate or get all the divisors of the n, right? Right? If let's say 1 and itself are the two divisors, then we will call it as a prime numbers, right? If it has other divisors except 1 and itself, then we will call it as a composite number. So we will start our I from 2 here. We are ignoring 1 and itself. If we are able to find out these divisors, then we will say it is a composite number, it is not a prime number. So in the while loop, what we have to do, again same condition, but less than or equal to the n in this case here. So what we have to do, if your n modulo I, let's say n modulo I, if it is equal to 0, then that means we got some divisor here, right, which is not 1 or itself. We ignored already 1 and itself here. So here what we have to do, just return false. That means we got some divisor except 1 and itself. That means it is a composite number. Here we will increment by 1 plus equal to generally. So this is the condition. Now what we have to do here, just return true. In this case, if it is not, let's say this is your while loop, out of this while loop you can return true here. If it is a composite number, we will get false. If it is not, then we will get true here if it is a prime number, right? Now let's run it for the same test inputs. Remove all these and run it. Now it is saying 5 is a prime number, we got true. 79 is also a prime number, we got true. And 39 is not a prime number, it is a composite number, it is false. So we got it perfectly right. So in the interviews, if you are supposed to ask such questions, you can simply implement using this mathematical condition. As you can notice, we are not iterating up to the n, right? You can also see the time complexity is also reduced here, right? It is improved as we are not iterating up to the n. If you notice, the best time complexity for this could be constant if n is even, right? So worst case will be under root n, big of under root n. That is going to be your worst case time complexity in this case. I hope you got this. So if you like the video, you can subscribe my channel as well.